Hi everybody, this is your fingers crossed last virtual lesson, and this is the most important lesson. It ties everything together, and we're going to do A, H, and K all together, and after we're done this lesson you will be able to have answered everything on your assignment, which if you have not seen it yet or not reviewed it yet, it is due on Sunday at by midnight. So our learning goals, we want to be able to correctly graph equations in Vertex form with all of the parameters and not using a table of values, which as of watching this, everything you've done in the workbook has been using a table of values, and then be able to determine the equation from a graph. So the first thing that we are going to go over here, our first example, describe the transformations and state the vertex of the new graph. So those are both written in vertex form, and just as a quick review, we've already seen it a couple times now. Vertex form looks like this: y equals a x minus h squared plus k. And here's, you actually are able to pick out the vertex just by looking at that equation. And here's how. The reason why it's called vertex form is because it gives you the vertex. And the vertex equals h and k. And h and k, those are like your x and y coordinates for your vertex. And there's one important thing to remember. So if you've been paying attention, or if you paid attention to the video lesson on what h does, h moves your graph left and right, but it was always opposite to what you thought. So if I take a look at a, for instance, my h value, it looks like it's x plus 5, but that actually moved my graph to the left 5. So it would have gone from 0 to negative 5. So one important point here to make, I like to think of it this way: h is always opposite, put that in quotations there, to how it appears. So the x coordinate of the vertex is always opposite to how it looks in the equation. I'm not going to go into too much depth on why that is, but just if you remember that simple rule, then you're going to be A-okay. So the first thing I want to do, I want to pick out the vertex, right? Describe the transformation, state the vertex. So V for vertex equals. Now we just learned here, the vertex is H and K. H and K. So my H value is there, and here's my K value. So we know for sure that it's going to be 7, that's my K value. And I've got to look down to this important point. H is always opposite to how it appears. And right now in the equation it looks like plus 5. What's the opposite of plus 5? Well, that's negative 5. So my vertex is negative 5, 7. Now we're going to describe the transformations. So again, we go left to right. The first thing I encounter is the 15. Is it positive or negative? That's a positive 15. So the first thing we write opens up. And if you've forgotten these things, refer back to your last 2 lessons. Then I encounter my A value itself is 15. If it's bigger than 1, it's vertically stretched. Remember, it becomes more narrow, so you're going to say vertically stretched, and don't forget the by 15. The next thing we encounter is the plus 5. If you remember from the last video lesson, it moves it left 5. That's backed up by our vertex. So right now our vertex, we have negative 5 as the x value. If you wrote moved right 5, that doesn't match what you just wrote for the vertex. Negative 5 means shifted left 5. So we'll just write, you can say shifted or moved. Moved left 5. That's done. And then the next thing we encounter is the 7 from our lesson on K. Moves it up 7. And again, that's backed up by our vertex, the y-coordinate. It's 7. If you said it moved down 7, that doesn't back up what you put in the vertex, or what you put there, negative 5 and 7. So moved up 7. Done. Perfect. B. Let's start with our vertex again. There's your H, there's your K. H is always opposite to how it looks. Right now it looks like negative 1. What's the opposite of negative 1? Positive 1. My K value, 9. There's my vertex. Now describe the transformations. First thing we hit's the negative. That means it opens down. Then we hit the 0.5. When A is a decimal or fraction, it's not stretched, it's wider. And remember, our math language was vertically compressed by, don't write negative 0.5. We've already taken care of the negative by saying opens down. So you're going to say vertically compressed by 0.55. And then we're going to write, so we took care of the negative, took care of that. H. If it appears negative, it moves right. That's backed up by what we put in the vertex. So moved right 1. And my K value is 9. Moved up 9. So this is a very important slide. You might even want to pause this, go back a few minutes, and then re-watch it, because this forms basically the basis of your understanding for the entire unit. Now the majority of the rest of this lesson is graphing. And as I've mentioned, so far in the practice work, we've only done graphing simple parabolas and using a table of values. And sometimes, even though table of values to me seem to be easy, oftentimes they're a point of confusion, or they're often messed up just due to calculator skills. But let's just pretend, okay, and you don't even have to copy this part down, just listen to it. Let's pretend like I gave you a table of values to complete for this equation. And by now, hopefully everyone knows. I'll show the first step. You put in negative 2 for x, so this is negative 2 plus 5 squared plus 3. And you'd enter that into your calculator just like you see it. Depending on your calculator skills, which is tough for me to assess from home, you should get 12. And then if you do that for the rest of these, you should get 19, and then 28, and then 39, and then 52. That doesn't look like things we've had so far. Anyone see any issues with that? Well, for one, my y values don't even fit on my graph, which that's okay, I guess, but I could change the scale. But still, it doesn't look like I have. Normally we've had repeating y values, or at least some repeat in the y column. I have nothing repeat. But now, if you're thinking maybe this isn't a quadratic, I like where your head's at. This is still a quadratic because it has squared, and that's the highest. And we know it's in vertex form, right? But all of this means is if I give you those values for x, which are kind of standard, all that it means is you're just graphing a certain chunk of the parabola. So what I just gave you right there from negative 2 to 2, what that really is like your graph, this parabola maybe looks like that. But all I've given you based off the x values is this little chunk here. So we're not getting this full all the way around parabola. And that's the problem, or one of the main issues, aside from calculator skills, this is one of the main issues with graphing using a table of values. And there's actually a way easier way to do this. It's going to become, again, I haven't told, usually I tell this on the first day, but I've taught this course, I'm not even kidding, probably going on 18, 19, 20 times so far since 2009. So, but the point I'm going to make is that, like, basically 99% of students prefer the way I'm about to show you for graphing versus table of values. And there are going to be some questions where I do kind of force you to do the way we're about to do if you happen to be that 1% that prefers to make a table of values. Anytime I don't tell you what method to use, if you are that person, you're welcome to make your own table of values, but it won't be provided to you. So that brings us to the step pattern. And the step pattern consists of 2 steps. The first step is always going to be plot the vertex, which we just learned. We can just read it right out of the equation. It's h and k, and h is always opposite. Step number 2, and I'm going to show you something to get step number 2. If for a second we were to graph the original, I mentioned it a few times, x squared. 0, 0, 1, 1, 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, and 9. So there's our standard x squared parabola. If you were to make a staircase from point to point, here, 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 you're going to notice a pattern. First of all, to go from this, we're going to start at the vertex. We're going to start right there. Over 1, up 1 unit. Then I go to the next point. Over 1, up, count the squares. 1, 2, 3 units. Go to the next one. Over 1, up, 1, 2, 3, 4, 5 units. And if I was to repeat the pattern on the left-hand side, it would be the same, which that matches our definition of a parabola, which we know it's a mirror image on one side of the vertex as the other. Now, even though I don't have the next coordinate on there, I'm sure most of you could probably pick out the pattern. 1, 3, 5, what would the next number be? It would be, hopefully you're thinking, 7. So we can actually use that pattern, those 3 numbers, to help us. So the first 3 steps, it's always over 1 from the vertex. But over 1, up 1, then up 3, then up 5. And what you do is you multiply that by your a value. So multiply that by the a value. So those are your 2 ways to easily graph. And it might not seem easy right now because it's the first time you've seen this, but trust me, this is super, super easy. And again, if you need to, pause it, come back to this, re-watch it again. Make sure if you're copying anything down, copy down that step pattern and highlight it, draw a cloud around it. So for the next few examples, we're just going to go through some graphing. Now, if you don't have nice grid paper, that's fine. You can just make an X and Y axis with a straight edge and a ruler and put some numbers on there with some ticks. But label your axes, X and Y. Now, step number 1, what did we just say? State the vertex. There's H, there's K. H is always opposite. What's the opposite of 5? Negative 5. And 3. Perfect. Already we're basically kind of halfway done. There's a point to plot. So negative 5 on the X and 3 on the y. That's right there. Already you have 1 point without having to do any work. Just read it right out of the equation. Step 2, those 3 magic numbers you have to memorize. 1, 3, 5. And we multiply by the a value. Well, what's the a value? Well, don't forget your general vertex form. The a value is the first number you come across. So my a value is right there, 1. So multiply by 1. And you can use a calculator, or if you're good at multiplying your head, anything times 1 is just itself. I'm not going to draw a circle, because those are our finalized steps. Now, how do you use those to get the rest of the points? Well, you start at your vertex, always over 1, and then up 1. So over 1, up 1 on both sides. Done. Now from that point I just made, over 1, up 3. Over 1, up 1, 2, 3 on both sides. That one's done. Now you notice I didn't do the 5th one, or the 5-unit one, because it doesn't fit on my graph. So, and having that many points that we have is enough to make our parabola. So if you ever can't fit the last one on, don't worry about it. If you can fit the 3rd one on, go for it. So hopefully that makes a little bit more sense for graphing parabolas. Our next one, label your x and y, put some numbers on a grid. Step number 1, state your vertex. There's h, there's k. H is always opposite. What's the opposite to -1? Positive 1. My k value, -4. There's a point, let's plot it. 1, -4, right there. Halfway done. Step 2, 3 magic numbers. 1, 3, and 5. What do you multiply it by? Your a value, which in this case is 2. What's 1 times 2? 2. 3 times 2? 6. 5 times 2? 10. From your vertex, go over 1, up 2. Over 1, up 2 on both sides. Perfect. Over 1, up 6 from the point we just made. Over 1, up 1, 2, 3, 4, 5, 6 on both sides. Done. Now the 10 point, that doesn't fit on our graph, so we're just going to stop there. Do your best to connect them with a smooth curve and then put arrows on the end. So hopefully now doing it a second time, it's even easier to you. A third time. Step number 1. Oh yeah, don't forget x and y, put some numbers on a grid. My vertex, there's h, there's k. H is opposite, so that's -6, and k is 2. There's a point, let's put it on. -6 and 2. Awesome. 3 magic numbers. 1, 3, 5. Don't forget to multiply. What's my a value? Well, it's the number out front, which in this case is -0.5. Might need a calculator for this one. 1 times -1/2, 3 times that's -1.5, and finally -2.5. So this is a good final example because it deals with negatives and it deals with decimals. So far we haven't had negatives, but we know a negative a value means opens down. So instead of going over 1 up, what do you think we do? We go over 1 down. And we're going to go over 1 down a half a square. So from our vertex, over 1 down a half a square on both sides. Okay, good. Now over 1 down 1.5. over 1 down 1.5 puts us right there. And my third point fits on this time. So over 1 down 2.5. Over 1 down 2.5 on both sides. Smooth curve, arrows on the end. There's my parabola. And it's opening down. It definitely looks compressed. I mean, it's a little bit wider than what it usually is. So that's good. Remember, as long as you can remember, even though we didn't do it for these ones, the descriptions, if there was a test, if this was a test question or an assignment question, you can always confirm what you drew for your graph with your descriptions. So if you wrote open down, your parabola should open down. If it's compressed, it should look wider. In this case, it's moved left. Does my graph back that up? Yes, it does. It's moved up. Does my graph back that up? Yes, it does. So those two things always help confirm each other. The next thing I'm going to go over is some vertex form in disguise, kind of like a transformer. And I'm going to write this to remind us. That's our vertex form. That's basically the holy grail of this unit, or at least the equation. So let's throw some, what about this? And I might ask you at this time, does that look like vertex form? Well, no, it looks like it's, I mean, I have the A value up front. There's no brackets. I'm missing the H value. Maybe the -2 is my K value. But no, it does not look like the standard vertex form we've been seeing. Does that mean it's impossible to graph? No. What if I wrote it like this? Does that look like vertex form? Well, hopefully you're saying, yeah, sure does. I got brackets, I got a H value, got squared. Those two equations, though, are the same thing. If you look at the first thing I wrote, so let's call this A, let's call this B. If you look at A, it's missing the H value. It doesn't have brackets. Now, I've put an H value in, but what is it? It's 0. That's not going to change anything. X minus 0 is still just x, and x squared is x squared. So this doesn't move left or right. But if you see an equation, again, like A, and it looks like you're missing the H value, just write it like I wrote it like B, and it's easy. If I was to ask you what the vertex is? 0, right? What's the opposite of -0? Positive 0, doesn't really matter. There's no opposite. It doesn't matter if it's positive or negative. 0 is still 0. 0, -2. What's your step pattern? 1, 3, 5 times 2. So even though it look confusing or not something we're not used to in A, actually, if we rewrite it, it's something that we're used to, and it's easily manageable. Let's try another one in disguise. Let's call this C. And this one's not as much in disguise as the last one. So that kind of looks like vertex form. We have our brackets. We have our squared. What does that look like we're missing? Doesn't look like I have a K value. So again, let's rewrite this. So call this D. Y equals -4, x minus 1 squared. It doesn't look like I have a K value. What number represents something that's missing? 0. And me throwing a 0 in there does not affect the equation whatsoever. Now that looks identical to vertex form. Most of you, hopefully by now, could tell me the vertex is 1 and 0. And then you go about your business graphing as normal. Doesn't move up or down, but it's shifted right. 1, 3, 5 times -4, and away you go. So just keep those in your back pocket in case you see them again in the future. Now I do apologize, this lesson's a little bit longer than the other ones. This is the most important one though. And then after you've learned this one, you've actually kind of pretty much learned everything for the whole unit, even though we're going to have lessons when we come back after the Family Day weekend. But so I'll give you a second. You might want to copy down that or quickly sketch that graph. And the next two examples we do are kind of working backwards. So if you're going to hit pause, copy this down, then come back, that's fine. To remind you, our vertex form looks like that. So now instead of me giving you the equation, and you give me the graph, I'm giving you the graph, you're going to give me the equation. I've scaffolded this for you, so I've broken it down into 3 steps. Find the vertex. Everyone hopefully should be able to tell me where the vertex is. Hopefully you're thinking right there. There's the vertex. What are the coordinates? -3, -10. Hopefully that was relatively easy. So the vertex equals -3, -10. The values of h and k. Well, I'm going to skip ahead to c. We don't know what our a value is yet, but I do know h is always opposite. So if I said that my vertex, by looking at the graph, is -3, when I throw it back into the equation, what should it be? It should be the opposite of -3. So x plus 3 squared, and then your k value. So the only thing we're missing is the a. How do you get the a from looking at a graph? Well, you have to remember 1, 3, and 5. And you kind of work backwards. So we start at our vertex, so there's my vertex. Over 1, up 1. Over 1, up 3. Over 1, up 5. My 3 magic numbers are 1, 3, 5. Based off this graph, I got 1, 3, 5. What does that mean I multiplied those numbers by? Well, hopefully you're thinking, if I'm supposed to get 1, 3, 5, and I got 1, 3, 5 in my graph, I multiplied by 1, which means my a value is 1. So b, a equals 1, and I'm putting it all together. And really all that matters when you're determining the a value from a graph is looking at this first step. Because that first step is always 1. And 1 times whatever the number is going to be that number. So for example, let's say I gave you this. Oops. Scratch that out. Let's say my parabola was this. And I asked you for the a value. Or even the equation for that matter. If we were to figure out our step over 1 and down 1, 2, 3, 4. Normally I'm supposed to have a 1. What does that mean that I multiplied by? Well, it means I multiplied by 4, obviously. And since I'm going down, it would be a -4. So if everybody gets that concept, again, if not, go back a couple minutes, rewatch this. Or, of course, ask me questions. So there's getting an equation from a graph. The last piece of the puzzle, the part we haven't tackled. Coming up with the equation from just information without graphing. So I'm going to write without graphing. That means we have to do some algebra. So we want to find the equation of a parabola that has a vertex of 2, 3 and passes through the point 3, 7. For these questions, which by the way, again, I mentioned it in the intro, there's no secrets. You know, I'm not here to trick you. You are going to see a question like this. It's on your assignment, and you're probably going to see it on your test, just so you know. So practicing this type of question is going to be very, very good for you, for your learning. We want to find the equation. The only equation I've shown you so far that's been of importance to us is this. So that's where everyone should always start. There is your roadmap. I need an A, I need an H, I need a K. Right off the bat, hopefully everyone should get the first step done, which I said the vertex is 2, 3. There's your H, there's your K. So y equals A. H is always opposite, don't forget. So it's positive 2 in brackets. When we throw it back in, it's going to be negative 2. And then plus 3. So as a very simplistic goal, everyone should be able, my expectation is everyone should be able to get that line done. If you get stuck, if you forget something, everyone should still be able to get there. And then I'm hoping everyone gets the rest of it, but for sure everyone should get that first line. So what's the only thing you're missing? You're missing A. And that's where I shouldn't say hard, but the more complex part comes in. Now, I don't typically give information for nothing in a question. Again, no tricks. So I've given you another point, 3 and 7. How could I use that? Well, that's a coordinate. And how do we write coordinates? One's the x, one's the y. So what we're going to do is we're going to sub 3, 7 for x and y. So where I see a y, right there, I'm going to put in 7. Where I see an x, I'm going to put in 3. And from there, you just do the math. So according to Bedmas, brackets, 3 minus 1 is, 3 minus 2, give the answer away, is 1. Now exponents, 1 squared is 1. Now I do want to point you to something. Normally we put the numbers out front of the letters. So at this point, I really want you to do this. Write out 1a plus 3. The reason being is because someone's going to be tempted to add 1 plus 3 is 4, and that's not what we want to do. That 1 is attached to the a. So we're going to come up here. 7 equals 1a plus 3. Now if I want to solve for a, isolate a. This was in your review note from the first day. And this is kind of going back to solving simple equations, grade 9 and 10. Bring that 3 over. When that 3 crosses the equal sign, it changes signs. So positive 3 is going to turn into what? Negative 3. 7 minus 3 equals 1a. 7 minus 3, 4. You can divide both sides by 1. It's not going to change anything. So we just got our a value. Now you're not done. You got to put all the pieces together. Remember, it's asking you for an equation. So our final equation, y equals 4 x minus 2 squared plus 3. And there is our final equation. So a lot going on there. That's definitely the one that's going to test our brains the most. But again, I'm telling you, I'm warning you, you are going to see this question, not necessarily these numbers, but you're going to see this type of question for sure pop up somewhere important. And again, if you have questions, make sure you let me know. So I think that's everything I have for you for this lesson. It's a big one. It's an important one. Puts all the pieces together. If you have questions, again, let me know. And I don't kind of rambling here, repeating information. And don't forget, you have an assignment that you have to do. You have to submit by Sunday, 11:30. And if you need help, let me know. If you aren't going to be meeting that deadline, again, please let me know. Communication, especially online, even though we're only virtual for 2 days, communication with me, even when we come back person to person, is key. It's essential. Please, please, please communicate with me as much as you possibly can.